Okay, so we've got three problems here that we're going to go through and try to solve. And so we're going to just take our time here and go through each one of these and come up with an answer and show you how we start this, go through this process start to finish. All right, so the first thing you might recall is that we have some equations here. And our equations are, so I'm going to just write these over on the corner. Our average velocity is the displacement divided by the time interval it takes. Average velocity is equal to initial velocity plus final velocity over 2. And then acceleration is equal to change in velocity over time. And that one is also equal to, acceleration is equal to v final minus v initial over time. I just wrote it that way to save room. And as you recall, that one can be rearranged to be this. Sorry, my handwriting is not the best there. Okay, let's try to clean this up a little bit, erase this. There we go. And try to draw that again. That should be a 0. There we go. Okay, so we're going to be using these three equations and obviously the one that got rearranged to solve these. So let's take a look here. And so we look at the first one. So a car maintains a constant velocity of 12.5 meters per second for 8.00 seconds. How far did it travel in that amount of time? So the first thing I like to do, as you recall, again, this is not something that's graded, it's just something that I recommend, is I write down all of my givens so I know what I'm working with here, and this kind of focuses me on what I need to solve for. So our average velocity was 12.5 meters per second for a time interval of 8 seconds. And so what they are asking for is a displacement. So if I go over and check my equations, there's only one equation that has displacement in it, and that is the very top equation there. So that's the equation we're going to need to use. So this is where I start grading. You write down the equation. Let me see the equation. Now, I recommend moving the equation around before you plug in numbers. So what we're going to do right now with this equation is we're going to multiply both sides by t, multiply by t, and what we end up with is that displacement is equal to average velocity times time. Now once you've done this, this becomes very easy because now all I have to do is plug in my givens that I've already written down and labeled into the same spot in the equation. So this becomes 12.5 meters per second times 8, and I'm going to forego the zeros for now just because I need the room. And so I've got seconds here that cancel with those seconds, and so I end up with a displacement of 8 times 12.5, which is 100 meters. Now, before we circle this or put it in a box or whatever we're going to do with it, we need to check our significant figures, and right now we have 1. All answers need to be in 3. So the easiest way to add sig figs would be to add the decimal point at the end. You can also, if you would like, add the bar above the 0. That will also be fine. Always put a box around the answer you want me to grade. Make it easy for me to find it. Now, let's take a look at the second problem. A runner moves 400 meters in 75.0 seconds. What is his or her average velocity? So again, we're going to write down all of the stuff that we know. So it moves 400 meters. That would be a displacement. We know that it's 400 meters. I'll put the decimal point there to remind us that that's 3 sig figs. They give us a time of 75.0 seconds. And they are asking for what is the average velocity. So that's what we're going to try and solve for here. Now, if we look at our equations, again, that first equation is the only one with displacement, and so it is the only one that's going to be worthwhile here. What's really nice about this one is we don't need to rearrange anything before we do anything. It's already set up exactly how we need it to be. So we're just going to plug in right away. So we're going to get 400 meters divided by 75 seconds. Let me go to the calculator real quick. 400 divided by 75. We get 5.3 repeating. 3 for forever. However, we can't have that many sig figs, so we have to round to 3 sig figs. So I'm just going to round it to 5.33. Make sure we slap some units on there and circle the answer you want me to grade. Okay. Finally, we come back down to the last one. So this one is dealing with acceleration. The first two we're dealing with constant velocity. Now, I'll give you a hint. Whenever you're dealing with a constant velocity, the equation that we use, that delta V equals average velocity equals delta D over T, that will be the only equation you ever use in that situation. You'll never use any other equation for constant velocity. All right. So now we're having a problem with acceleration. So we're going to need a different equation because that one won't work for acceleration. So we're having to solve for the acceleration. Well, let's take a look here and see what we have. So what is the acceleration of a vehicle traveling 36.0 meters per second, coming to a complete stop in 4.52 seconds? All right. So that would mean our initial velocity here is the 36 meters per second. Now, I chose 36 meters per second because that's 80 miles an hour. So this is how fast you'd be going on the interstate. Our final velocity would be 0 meters per second because we're coming to a stop. The amount of time that takes is 4.52 seconds. Now, again, this part is not graded right there, but the part that starts grading is right now. So we need to pick an equation. Well, we have 2 velocities and a time. So either of the 2 bottom ones will work. The one that works up a little bit better is this equation here is A equals V final minus V initial over time. Remember, VI and VO are the same thing. And so this is, remember, delta V is VF minus VI. So that is the same thing. It's the same equation. So my final velocity here, be disciplined on what it is. Again, this is why I label what everything is over here. It keeps it straight. My final velocity is 0. It needs to be there. That's meters per second. Minus my 36 meters per second over the amount of time it took, 4.52 seconds. We punch this into the calculator and round it to 3 sig figs. So I'm going to do that all in one step. And we get 7.96 meters per second. But it's not just that. It must be negative because it's 0 minus 36. So it is a negative 7.96 meters per second. This makes sense because what is this car doing? It is slowing down. So that means that if it has an initial positive velocity, that means the acceleration must be negative because it has to be the opposite sign because the car is slowing down. You'll remember that from the direction of motion worksheet that we went over earlier.